Welcome to a logical reasoning video on series from careerright.com. This is an important topic of placement tests, job interviews and entrance exams where many candidates struggle. They are not able to quickly find the relation in the series and hence they waste a lot of time on the question. Many even at the end leave the question and some of them don't even attempt the question. But today we'll see some approaches and tips to quickly solve the questions on series. Along with this, you can check out latest job offerings in the market on careerright.com. The profile which you submit will be shared directly by us with the employers. You will also get to know of interview experiences shared by other candidates. So now let's start with series. First, let us take a look regarding types and tips of series. Okay, now over here types means series can be of three major types. Okay, 99% sums are related to this only. One is numeric, that is related to numbers. Second is alphabets, that is letters, and the third one is alphanumeric, that is letters plus numbers, combination of letters and numbers. And the fourth type is generally asked, that is symbols. We are not going to deal with it because generally symbols has no logic. Whatever logic is needed for solving symbol series, it is already given in the question. Okay, so no need to consider symbols over here. Here we will focus on the most important topics where 99% sums are asked, that is numbers, letters and letter numbers or alphanumeric, right? Now series sums can be asked in three formats. Okay, these are three types. There are three formats of sums. One is find the next number in the series or find the next group of letters or next letter in the series. Then is find the missing number or the missing alphabet or the missing group of alphabets. The third one is find the odd man out or find the odd number or the odd alphabet or the odd group within the given series, right? Now we have seen the types, we have seen the format of questions. Over here in the types, these three types have many subcategories. Okay, these subcategories are, you have already seen these subcategories, it's nothing big in it. We are going to see each and every subcategory so that you will be able to understand what kind of sums are asked and how to approach them. Okay, now let's move on to some tips regarding series. While approaching the series sum, please understand the first thing you have to do is to find the relation between the given elements. Okay, and second sum is using the relation solve the question and get the answer. Now how to find a relation, okay, or what kind of relation we should search. Now whenever we are talking about finding a relation, let us assume that this is a series 3, 4, 5, 6. This is a series. Now in it, say if we take this element, we have to find relation of this element with the previous element and the next element. Then if you move on to this element, find the relation between previous element and next element. If we move on to this element, find the relation between previous element and next element. Then you will get a pattern. Okay, this pattern is what we need, and using this pattern we can solve the question. So now how to go on or how to approach in finding the relation? Very easy. What you need to do is that, say this is a series. Okay, this is a series 1, 2, 3, 4, 5, 6, and we have to find the pattern in it. What you need to do first is let us find the difference between two elements. Okay, this is for only for the number series. Okay, I'm not talking about letters and alphanumeric. For that I'm going to tell you a different strategy, but for numbers it is important. Please pay attention over here because this will help you get the series pattern very quickly, okay, or easily. Now over here let us find the difference between two numbers. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. Here you are seeing that there is a steady difference or a constant difference. If the difference is not constant, okay, if the difference is like first there is a difference of 1, then between the second and third element the difference is of say 7, then third and fourth the difference is suddenly 25, and fourth and fifth difference is say 200, fifth and sixth difference is say 5500. So this difference is increasing arbitrarily and it is very huge. It is not going steadily, something like that. It is increasing it is going very high. There is a very steep rise in the difference. In such cases, always remember that the series must be related to square of number, cube of number, or multiplication, okay, or simple multiplications, right? If this is the case, if the difference between the numbers or elements is very high, it is increasing very highly or very quickly, that means the series is related to squares of numbers, cubes of numbers, multiplication of numbers, okay. Now we'll tell you what exactly we mean by square, cube, multiplication, but just remember this. I'm going to repeat it afterwards also, but still remember it. If the difference is constant like this, 1, 1, 1, or if the difference is increasing very slowly, like here the difference is 1, then here the difference instead of 1 it becomes 3, then here the difference becomes say 7, then here the difference becomes say 10, here difference becomes say 15. So it is increasing, but it is slowly increasing, it is not increasing very arbitrarily and all that stuff. So over here in this scenario, the series must be related to addition, okay, addition, subtraction, multiplication, division, okay, or the series might be of a prime numbers, or it might be a Fibonacci sequence. I'll tell you what all these things are: Fibonacci sequence, prime numbers, addition, subtraction, okay, but just listen to what I am saying. So these might be types. There are many more, okay, miscellaneous types also are there, or combinations is also there. So these two rules which are there, they are very important while approaching a sum related to series. Always keep these rules in mind. That is the reason I have told you right at the start, okay. Now what we will do is, now we will first see what are the type of series, okay, we will see what is numeric series, what is letters, what is alphanumeric, and then we'll try to, while solving the sums, we'll try to understand how to approach the sums related to series, okay, a more detailed approach as to how to identify what kind of series it might be, okay. Moving on to the first type, that is the numeric series. Number series, numeric series or number series has a lot of subcategories, okay. We'll denote a few prominent ones or the basic ones which are extremely important, and most sums are related to that, okay. First one is related to addition or the addition series. Take a look at this example: 19, 25, 32, 40, question mark, and we have 59. Now in this series, what we have learned first, always find the difference. 25 minus 19 is 6, this is 6. 32 minus 25 is 7, 40 minus 32 is 8. That means that 19 plus 6 you will get 25, 25 plus 7 you will get 32, 32 plus 8 you will get 40. So here we are finding difference. So here a pattern is emerging, that first 6 is added, then in the second element 7 is added, in the third element 8 is added, that is one more. So in fourth element how much should be added? Plus 9, okay. Then you will get some answer over here, and in that you will add 10 and you will get 59. So let's see whether we are right or not. 19 plus 6 is 25 plus 7, 32 plus 8 is 40 plus 9 is 49, and 49 plus 10 is 59. So this series looks complete. It is following a pattern. First 6 is added, then 7, then 8. Such kind of series is addition series, where things just are just added, okay. To the previous number, you add something to get the next number. Again, you add something over here to get the next number. Now here there's plus 6, plus 7, plus 8, plus 9, plus 10. Okay. They might even have add plus 1, plus 1, plus 1, or plus 2, plus 2, plus 2, or they might even add say odd numbers, right? So first they'll add 1, then they'll add directly 3, then they'll add 5, then they'll add 7, then they'll add 9. Only odd numbers might be added, or only even numbers might be added. Addition can be of anything. So when you determine that it is an addition series, you just need to find out the pattern as to what exactly is being added. Same way you have the subtraction series. Okay, in subtraction series, instead of addition it is subtraction. For example, 102, 85, 68, question mark, 34. What is the difference? 102 minus 85 is 17, 85 minus 68 is 17. So 102 minus 17 is 85, 85 minus 17 is 68. So here also it should be subtracting minus 17, subtracting 17, that is 68 minus 17, you will get 51. Again from here you subtract 17 and you will get 34. So here a constant value has been subtracted. Okay. So whenever a series is increasing, it is addition or multiplication. Okay. next number is greater than previous number. Okay, so 32 is also greater than 19, 40 greater than 19, 49 greater than 19, 25. So it is increasing like this. So it is addition or multiplication series. In subtraction, the numbers decrease like this. Okay, even in division, the numbers will decrease, right? Now next, like addition, subtraction, like we have talked about right now, multiplication series. In multiplication series, the number is multiplied by some number to get the next number. Like I'll give you an example. Take a look at this series: 1, 2, 6, 24, 120. 1 to 2. Okay, what is the difference? The difference is 1. 6 difference is 4. 24, here difference is 18. 20 minus 24, 120 minus 24, difference 96. See, the difference is increasing very quickly. That means this must be related to multiplication. Okay, so let's try to think of some multiplication, like 1 into, what is the relation? 1 into 2 is 2. Okay, so we found this relation, 1 into 2 is 2. 2 and 6, what might be the relation? We know 2 into 3 is 6, correct? Now 6 and 24, what can be the relation? 6 into 4 is 24. So what is happening is that the next number which is there, it is taken over here and it is multiplied by something. It is first multiplied by 2, then 3, then 4. So this must be multiplied by 5, right? This should come over here and this must be multiplied by 5. So 24 into 5 becomes 120, right? So what will be the next number? Write it 120 over here. Here it is 5, 2, 3, 4, 5, 6. 120 into 6 will give you 720. This is the answer. This is multiplication. It might also happen that each of the number is multiplied by a constant number. Okay, like say 6, 12, 24, 48, 96. 6 is multiplied by 2, you get 12. 12 is again multiplied by 2, you get 24. 24 is multiplied by 2, you get 48. 48 is multiplied by 2, you get 96. Okay, such multiplication can also be there. Same way, there is division, there is nothing to it. Okay, this is the division series. Take a look at it. Okay, 2, 1, 6, 72, 36, 12, question mark 2. Okay, here the difference which is there, it is falling. Okay, here we saw if it is rising very quickly, it is multiplication. If it is falling very quickly, exactly opposite that it is will be division. Okay, let us see what division. 216, when it is divided by 3, you will get 72. 72 when you divide by 2, you will get 36. 36 again when you divide by 3, you get 12. So divide by 3, divide by 2, divide by 3, divide by 2. Answer here it will be 6. Again divide by 3, 3, 2, 3, 2, 3, you will get answer as 2. So our answer is correct. The here it will come, here the answer will be 6. This is division. We are going to see examples of all of these. So don't worry, don't panic, there is nothing to it. It is very easy. Now after these basic numeric series, let us move on to some special numeric series. Now special numeric series, I mean they are not that special, I just said it for like effects purpose and all that stuff, but over here see there are some numeric series which you should know for sure, because many a times sums are asked on them. The first one is regarding, okay, squares, that is squares of a number, squares, cubes and the series which are near to it. I'll explain what it means near to it and all that stuff. Okay, you must know squares of numbers, squares up to 30, and you must know cubes of numbers up to 10, because it is very useful to decipher the series. Also it would be useful for your quant, right? So first of all, let us see an example of square series or numbers near it. Say take a look at this series, 0, okay, not this, 0, 3, 8, 15, 24, 35, question mark, 63. Now if you observe closely, what do we see over here? Difference is 3 minus 0 is how much? 3. 8 minus 3, difference is 5, here difference is 7, here the difference is 9, 11. Okay, question we don't know over here. So it is increasing. Okay, it is steadily increasing, right? So this must be related to addition, subtraction, multiplication, something like that. Now over here we have taken smaller values. Okay, if we go on increasing over here, you will realize that it is increasing more and more. The difference is increasing more and more. Okay, over here if you observe very closely, this is 0. 0 is nothing but 1 minus 1. 3 is nothing but 4 minus 1. 8 is nothing but 9 minus 1. 15 is 16 minus 1. This is 25 minus 1. This is 36 minus 1. Question mark, we don't know. This is 64 minus 1. And this is nothing but 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. So by default here it should be 7 square. This is 8 square. So 7 square minus 1. Now you will say that by looking directly at this, how will we guess that it is a square series or something like that? That is the thing of series. Whenever you get a series, if you are not able to think about what series it might be, you have to apply some tricks like, okay, is this nearer to some square? Is this nearer to some square? Is it a square of some number? Like that, okay? Here it is 4 square minus 1. It is 4, 2 square minus 1, 3 square minus 1, 4 square minus 1, all that stuff is given over here. This is what we mean by square series or a series which is nearer to squares. If you talk about cubes, what you can have, this is a cube series, 64, 125, 216, 343, okay? Observe carefully, this is 4 cube, this is 5 cube, this is 6 cube, and this is 7 cube, okay? These are the cubes. So this is a series. Now after this, let's take a look at another very important special series, and that is nothing but prime number series, okay? You know what are prime numbers? Prime numbers are those numbers which are divisible by themselves and 1. Apart from that, no other number, okay? So we know 1 is not a prime number. Prime numbers start with 2, 3, 5, 7, 11, 13, 17, 19, and so on. These are prime numbers. This is the prime number series. It might happen that they might give you an addition series, okay? And in that, while adding, first they'll add 2, then they'll add 3, then they'll add 5, then they'll add 7, okay? So such kind of, you need to find out what the addition is, and then you need to see, okay, this is like prime numbers are getting added. So after 7, 11 is the next prime number. So in the next element, I have to add 11. After 11, 13 is the next prime number. So I have to add 13 in the next element to get the next element, okay? This is prime number series. The numbers which are not prime are called as composite numbers, okay? The rest of the numbers like 4, 6, 8, okay, 9, 10, all 12, all these numbers are composite numbers because they are not prime. Now after prime number series, a very important series I am going to talk about, that is the Fibonacci series. Now what do we mean by the Fibonacci series? Over here in Fibonacci series, the best part about Fibonacci series is that, say this is first, second, third, fourth, fifth, sixth element, okay? Addition of this element and this element will give you this element. If you want this element, then add this and this, you will get this element, okay? If you want this element, you will have to add this element to this element, and then you will get this element. So Fibonacci series always starts with 2 ones, that is this. See, I'll draw over here 1 and 1. Fibonacci sequence starts with this and it goes on up to infinity. So this is the first element, this is the second element. So what is the next element? Add this and this. What you will get? 1 plus 1 is 2. What is the next element? Add the previous 2 elements. 2 plus 1 is 3. Next, 3 plus 2 is 5. Next, 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21. 21 plus 13 is 34. 34 plus 21 is 55 plus is 89. 89 plus 55 is 144, and so on, okay? This is the Fibonacci sequence or the Fibonacci series. So in exam, okay, or in paper, they might give you the series right from here to here, like that, in between only. So you just need to check whether addition of these two numbers is this, these two numbers is this, these two numbers is this. If that is the case, that means that it is a Fibonacci sequence and you just need to add these two numbers to get the next number, okay? After Fibonacci sequence, I am going to tell you a very important point. Please pay attention, okay? It is really very important. Sometimes it might happen that a series is given, like say 1, say 2, 3, 4, 5. 8, 7, 6, 5, 4. Okay, this series is given. Now here you observe it increases. Here from 1 to 8 there is an increase. 8 to 2 there is a decrease. 2 to 7 increase. 7 to 3 there is a decrease. So if there is such increase, decrease, increase, decrease, that means that there are two possibilities. One is there are two different series, just like I wrote over here 1, 2, 3, 4, 5, and other series I wrote 8, 7, 6, 5, 4. There might be two different series, or there is another possibility, that is that two different operations are going on. That means once it is getting here some addition is there and here subtraction is there. Here addition is there, here subtraction is there. Something like that is going on. Okay, so two different operations are going on, or they are two different series. You have to think in these ways. We are going to see an example of it, but still I am telling you right now. I'll explain it again during the example also. Apart from this, say if you are not able to understand how to solve a sum, what you need to do is you just need to break the number and analyze each number individually. That also we are going to see. It might also happen that, say if a series is A, B, C, D, E, F. So instead of giving directly A, B, C, they might write C, B, A. They might reverse it. Okay, F, E, D. Okay, they might reverse it and give the series even. That is the possibility. You have to check that also. Okay, so we have seen some of the series right now. Let's move on to, we have seen numeric series. Let's move on to the alphabet series or the letter series. Alphabet series are a bit easier than the number series or the numeric series, and the thing that is going to help you a lot when it comes to alphabet series and alphanumeric series is this: A to Z. You have to write always, whenever you go to the exam, always write A to Z and their positions. That is, A comes first, B is second, Z is 26th. Okay, and reverse position. This is another very important concept that you should know. Reverse position of the letters. That means if Z is considered as 1, Y will be 2, X will be 3, and A will be 26. How to find reverse position? We have checked that out in the previous logical reasoning videos. Okay, but again I'll also tell you over here. Total number of letters are 26. Okay, so what is 26 plus 1? 27. So if you want the reverse position of any alphabet, just subtract the original position from 27. Let's take an example. D over here, original position is 4. I want the reverse position of D. 27 minus 4. 27 minus 4. What is the answer? 23. This is the reverse position of D. This will become 24, this will become 25, and A will become 26. Okay, see how easy it is. Remember, subtract the original position from 27 and you will get the reverse position. When you go in exam, always write this down, write the reverse positions also, so it becomes very easier to calculate. Okay, now we will see how this chart of A to Z helps in alphabet series later on while solving the sums. But over here in alphabet series, okay, I'll draw a line over here. Okay, there are two type of sums which majorly are asked. 99% times these two types are there. One is regarding vowels and consonants. Okay, vowels and consonants. What are the vowels? A, E, I, O, U. Okay, A, E, I, O, U. These are the vowels. And related to this, the question might be asked, or they'll omit the vowels and they'll just keep consonants. That is the rest of the letters, and a question would be asked on that. And the second would be the position of the alphabet. Okay, the alphabet which we have like A to Z, their position. Question might be on their position. Like first A is there. Okay, then they'll skip two letters and directly write. They'll skip B and C. B and C is skipped, and they'll write D. Again E and F, two letters are skipped, and they'll write G, like that. So it is based on position, right? So there are many types in this. We are going to see it in example, but remember that there are only two types mostly, and the best way to tackle the sums related to alphabet series is this chart, A to Z. Now here also you should see the position of the first alphabet, see the position of the next alphabet, then the third alphabet. There are two type of sums that may be asked. It might be like this: A, B, C, D. That is each element is just one letter, and sometimes there may be groups instead of letters, like A, B, C, D, E, F, G, H, I, J, K, L, and we have to find the next three letters. Okay, so here what we have to do, take the first letter, find the relation with the second letter, take the second, find the relation with the fourth, and also we have to find the relation of this group with this. Okay, so such things are there. It is very easy actually. Once you draw the chart, you will very easily be able to guess the answer or the pattern. Let's take a look at few examples so that it would become more and more clear. Now look at this example, CEH, okay, question mark, then you have OQT, then we have UWZ. We have to find what comes in place of question mark. C, this is the first letter, okay, C is over here. E, one position, second position, so plus 2, you will get E. E, F, G, H, okay, plus 2 again. What you will get? No, actually C, D, E, only one over here, only one skip is there, and from E to H, one skip, second skip, okay, so 2 skips are there, and then the third letter is written. Over here for OQT, O, again one skip, O is over here, one skip, you get P, okay, one skip. Q and T, one skip, second skip. There are 2 skips over here, again here also one skip, here also 2 skips between W and Z. So whatever answer will come over here, okay, whatever options would be given, A, B, C, D, E, whatever options are there, we have to see that in that option the whatever is given, like for example they give say M, O, R, we have to as A, then we have to see if between M and O one skip is there and O and R 2 skips are there. If that is the case, that will be our answer. Okay, see how easy it is using this table or this whatever rough note you have written for of A to Z and the positions. Let's take another example, B, D, A, F, H, E, then question mark, then N, P, M. Now over here B and D, what is the difference? Here B is over here, B and D, difference is 1, so there is only one skip, okay, C has been skipped, B skipping C, then we get D, okay, then D and A. Now D, A comes before D, so 1 before D is C, 2 before D is B, and 3 before D is A. So what we can say, between D and A the difference is -3, okay, 1, 2 and 3, this is the third, so -3. D to A, when we go 3 places back we will get A. Same way over here, F, G, G has been skipped, so +1, and directly we get H. Now H to E, again 1 over here, look at the table over here, E and H, 1, 2 and 3, again -3 skip. Here also N to P, 1 skip, and P to M we have to go backwards 3 times, that is -3, the third letter backwards would be M. So whatever would be the answer over here, we have to see that that group has this pattern, right, +1 and -3. Now over here we have BDA, we have FHE, we have NPM. There must be some relation between this group and this group. Let us find out what the relation is. There are 2 ways to think about it. What you can think is that after A they have given directly F, okay, A to F, what is the distance? 1, 2, 3, 4, okay, 4 is the distance between A and F, F is the 5th, distance is 4 and 5th is F, so distance is 4. Now E to the next letter, now this group has 1, 2 and 3 letters, so distance between E and this first letter would be how much? Again 4, right? What is it? 1, 2, 3 and 4, it would be J, so it has to be J over here. Also we have learned that from J, okay, when we skip 1, the next one will be the second letter, J, skip 1, don't write K, it would be L, L comes over here. Again from L we have to skip 3 in the opposite direction, that is we have to go reverse, we have to go back 3, 1, 2 and 3, what we get is I, okay. From I, now let us check this 4, okay, whether it is 4 or not. From I, 1, 2, 3 and 4, we get N as the 5th. So we are exactly right on track and we have deciphered it properly. This is how you identify it. Now there is another logic to identify the connection between these 2 elements or these 2 elements. Let us see what. Over here what do we have? We have BDA, okay. Now we know A comes before B. So what we can write? We can write this as A is there, then B comes, and then D comes. We skip C and then D comes. Over here, E is there, then F comes, then we skip G and H comes. Just like this. Over here, let's not go over here, we'll go over here. M is there, then N comes, then we skip O and then P comes. Correct? This is also a logic. Also, you can see D, A, then B, then D, and this after this D, what comes after D? E. E is over here at the last. Correct? E, F, H. H is over here. What comes after H? I. I should be also here at the last. Then from I, what comes is J. We skip K and we get L. After L, what comes? M comes. So M must be here at the last, which is already there. After M, N comes, N, skip O and we get P. This is also a logic. You can use any logic, just get the right answer. Okay. Moving on to another series. Let us see H, F, D. Okay. N, L, J, question mark, O, X, V, T. Now let us see whether we can find some relation. Okay. Now H, F, D. So H is over here, F is over here, D is over here. Oh, we are going in the opposite direction. H, then F, then E. In the reverse direction we are going. So let us now say, let us see, or we can, what we can say is that one skipping is there. H, they have skipped G, then F, they have skipped E and then D. Okay, in opposite direction. So J is there. Where is J? J is over here. L. Okay, J is over here. L is over here. N is over here. J, they have skipped 1, K, then they have gone to L, they have skipped 1, then N. Right? Over here. So here what is happening is that H, F, D, we are going in opposite direction like this. N, L, J. Okay. First is N, then L, again over here in opposite direction. J, L and N. J, L, N, or N, L, J. Right? N, L, J, again we are going in this direction. This we don't know, we have to go in this direction only. Let us check from here. T, V and X. First we, or X, V and T. First we have X, then we have V, then we have T. Again we are going in this direction. Right? So here also we will go in the opposite direction. O. Okay. We don't know what is over here, but we know O as the last element. So we have to skip one. Since we are going in this direction, this is the last element. So we have to now go in this direction to find the answer. Okay, what comes before O? We have to skip P. We will get Q over here. Okay, again skip R. We will get S over here. So answer is SQO. If you try to mark SQO, you will get S, then we skip R, Q, then skip R and O. That is, again we are going in this direction. So our answer is correct. Answer is SQ. Instead of question mark, SQ will come. See how easy it becomes using the table of A to Z. Now let us take a look at some of the alphanumeric series. Alphanumeric series has alphabets and numbers in it. Okay. Now again in alphanumeric series, the most important part is this chart A to Z and the position of the alphabets as well as the reverse positions. Okay. And how to find reverse positions, that we have seen. Subtract everything, subtract the original position from 27, you will get the reverse positions, right? Now in alphanumeric series, generally how to find out the relation. I'll give you an example of alphanumeric series right now over here, so you'll understand what exactly we mean by alphanumeric series. 2E2, 1H9, 1K6, then we'll have 1N3. Find the next one. This is 1. Okay, not I. This is 1. Now over here, this is an alphanumeric series where we have alphabets and numbers. What to do whenever you find an alphanumeric series? The first thing that you have to do is, whatever numbers is there in the group or element, you have to see if they are related to the position of the alphabet. Okay, position or reverse position of the alphabet, right? So 2 and 2, if they are related to position of E or not, or reverse position of E or not, that we have to check. Now after that, say if it is not related to position, you have to find whether these numbers are related to each other. Like if there is each other, okay, I'll write it over here, each other, so you will not forget, make a note of this. Now 2 and 2, we know 2 is equal to 2. 1 and 9, we don't know what relation it is there. 1 and 6, again don't know what relation. 1 and 3, don't know what relation. So over here, should try to find if they have any connection with each other. Okay. Now, if that is not the case, then try to find relation with numbers of other groups, with numbers of other groups. Like for example, here we have 2 and 2. Okay, 2 and 2, is it related to 1 and 9? Is it related to 1 and 6 or 1 and 3, or this 2 related to 1 or this 2 related to 9? Like that we have to try to find. Or what you can do is take this as 22, take this as 19, something like that. We have to find the relation. Okay. Now, even if that is not possible, then actually parallel to this, we also should check out if the letters are connected to each other. Same thing we have to do for letters also, right? So whatever alphabets are there, we have to find out the relation for those also. And in this trial and error, you will get the pattern. Now we'll see an example. We'll solve this example also, as well as we'll see another example as to what we are talking about. Now this sum which we are saying, or the question which we are seeing over here, it can be solved in two ways. There are two logics. You can use any logic. Okay, I'll explain both the logics. Over here 2 is there, 2 is there. What we have to check whether it is related to position of the letter. So 2 and 2, no, position of E is 5. So 2 and 2 is not related. What is the reverse position of E? 27 minus 5, 22. Okay, this 2, this 2, this 2, this 2. Let's check over here. 1, 9. Okay, what is the reverse position of H? 27 minus 8, 19. Yes, we are finding a pattern. 1, 9 means 1, 9 over here. So 1, 6, 1, 3. These must be the reverse positions of the letters, right? So whatever option is there, we have to check. There we have to see if whatever the option is given, it has the, for example, if the option is like this, P and say 0, 9 or 9, 0. If this is the reverse position of P, then we can select it as the correct option. Okay, so check out the options. Now what is the second logic? Over here 2 and 2 is 22, 1 and 9 is 19, 1 and 6 is 16, 1 and 3 is 13. If you observe closely, what is happening is that minus 3, minus 3, minus 3. So by default next one will be minus 3, this will be 10. So that means the three positions which are there, this is 1, this is 0. We have to find the letter E and H. E is over here, H is over here. There is a gap of 2. Okay, they have skipped 2 letters, H and K. One letter skipped, second letter skipped, K. K and N. One letter skipped, second letter skipped, N. N and next what is there? One letter skipped, second letter skipped, Q. So answer is Q. So answer is 1QO. So this is the second way to solve the same sum. You can use any number of ways, just get the right answer. Let's take another example. H8, L12, O15, S19 and next one. Okay, here H8, L12, O15, S19 is given. What is number? Check if it is related to position. H position is 8. Yes. So 8th position is of H, so H8. 12th position is of L, so L12. O15, O is 15, S is 19. What will be next? Now, how to find next? Say if no options are given, what you will do? Or if in option, say options, I'll give you 4 options, so you will understand what I am talking about. U21, V22, R18 and X24. Okay. Now in all the 4 options, the letter which is there and position is correctly given. U is 21, V is 22, R is 18, X is 24. So what will be the correct answer? How you will write? Now comes that the number has to be connected to the other numbers or the numbers of the other group. This is one group, this is second group, third group. So 8, relation of 8 and 12 must be found out. 12 and 15 must be found out. 8 plus 4 is 12. 12 plus 3 is 15. 15 plus 4 is 19. Okay, now here we are seeing a relation plus 4 plus 3 plus 4. So here it will be plus 3. 19 plus 3 is 22. What is 22? V. Answer is V22. See how easy it is with the chart which is given. Okay, so moving on, we'll see some of the sums related to series. We'll solve them and we'll see how we are approaching the sums in exam. Also, please don't forget to log into careerright.com. to check out the latest jobs in the market, go on to the job forum of careerright.com. Question number 1, 2, 5, 10, 17, 28 question mark. Let us try to find out what exactly is the next element in this series. Now first I will tell you what to do. Now whenever if you are not able to find the series directly, or if you are not able to tell what series it is by observation, what you can do is first try addition. Okay, addition series, try to see if it is an addition series, then try if it is an subtraction series, then try if it is a multiplication series, then division series, then see if there are prime numbers involved. Okay, if all of them are prime numbers, or prime numbers are being added or subtracted, multiplied, something like that. After that, after prime numbers still you are not getting, try for Fibonacci. Okay, Fibonacci sequence, see if it is a Fibonacci sequence, right? And even after this, if you are not getting, whenever, what you can try is that you can try a combination of all these methods, right? You will get the answer for sure. Most of 99% times you will always get the answer from these methods. Now sometimes what will happen is that the series would be really huge, like see, I will give you an example, 4895, 4897, 4899. Okay, now I know I am just adding 2, 2, 2, but let us assume that this is a series, and in this I am not able to decipher, and the numbers are also looking big. So what to do? What you can do over here is you can break this number into two parts, 48, 95. Same way you can analyze this 48, you can analyze this 95. Again divide it 48, 95. You can see that 48 gets repeated. Okay, 95 to 97 plus 2 is there. Okay, over here also 48 repeated, 97 to 99 plus 2 is there. So like this you can break that, you can even break this 4895 into 4 parts, this, and check. Okay, 4 gets repeated, 8 gets repeated, 9 gets repeated, 5 plus 2 is 7. You can try to analyze this way also. Sometimes that if you see the series might be like this, 5, 8, 9, 5, then 6, 8, 9, 5. So over here they might, what they are just adding 1000, or what they might be doing is that 4895. If you reverse it, you will get 5984, 5985, 5986. So this is also a series. Just like ABC, they can write it as CBA just to confuse you. They might do it with numbers also. So please pay attention. Let us solve the first sum. 2 and 5 difference. What we have learned, first see what the difference is. 2 to 5 difference is 3, 5 to 10 it is 5, 10 to 7 7, 7 to 11. So what will be next? Over here if we see, observe carefully, these are nothing but odd numbers. But what are the odd numbers? 3, 5, 7, 9 is also odd number, but 9 is not included. Then these must be some special kind of odd numbers or some special numbers. If you observe carefully, you will know that these are prime numbers, 3, 5, 7, 11. So what is the next prime number? 13. So 28 plus 13 will be how much? 41. Okay, 8 plus 3, 1, 2. Okay, so 41. So next number which is there is 41. 41 is our answer. See how easy it is. Moving to the next question. Question number 2. Let us see, here you have to find the missing element. What is the difference? 34 and 21. The difference is 13. 34 and 55, 21. Okay, 55 and 80, 34. Okay, now can you observe? Okay, this also difference 55. Can you observe something? In the difference you get 21, 34, 55, which are nothing but these numbers. When such a thing happens, directly you should know that it is a Fibonacci sequence. Okay, please remember, very important, right? It is a Fibonacci sequence. How? Let's see. 21 and 34. 34 plus 21 is 55. 55 plus 34 is 89. 89 plus 55 is 144. So this will be what? 144 plus 89. What it will be? 144, 89. 9 plus 4, 13. 1, 4, 12, 13. 233 is the answer. 233. This will be the next number in the series. Moving on. Now next is L, O, J, Q, H, and we have to find the other one. Okay, I have purposefully written this A to Z because in exam you will always be having this in rough space. Okay, and you can refer. What is the first one? It is L, then is O, then is J, then is Q, then is H. So it is like we are going this way, again coming this way, again coming this way. This is like what we have seen in number series. There is an increase, there is a decrease, there is an increase, there is a decrease. So that means that two different operations might be happening over here, or there are two different series. Okay, so how the series might be? It might be like this, and this might be a series. Let us see. L, J, H. L, where is J and H? So we are going in this direction. L, skip 1, J, skip 1, H. Okay, this is a sort of a pattern. Let's see the other one. O, Q, question mark. We have O, skip 1, Q, and the other one, what it will be? As per this pattern, we are going in this direction. What will be the next one? Skip this, S. So answer is S. See how easy it became. Even if there are two series, they have combined it, tried to make it difficult. Using this chart, it becomes very easy to pinpoint or find the pattern and solve the question. Moving to question number 4. USPLG question mark. Okay, where is U? USPLG. Okay, over here, can you see this much gap, this much gap, this much gap, this much gap? So U, skip 1, okay, S, then skip 1 and 2, then P, then 1, 2, 3, 3 are skipped, and then L, 1, 2, 3, 4, 4 are skipped. Then so skipping which is there, we are going in opposite direction like this, and skipping which is there, first 1 is skipped, then 2 are skipped, then 3 letters are skipped, then 4 letters are skipped. So now 5 letters must be skipped. 1, 2, 3, 4, 5 are skipped. Answer is A. Moving to question number 5. Okay, now we are here with question number 5, the wrong term question. Okay, the third kind of sum which can be asked in series. Find the wrong term in the following series: 10, 14, 28, 34, 64, 68, 136. 10 and 4, difference is 4. 4 and 28, difference is 14. 28 and 34, difference is 6. 34 and 64, difference is what? What is the difference over here? 30, 64 and 68, difference is what? 4. 68 and 136, difference is what? This is about 68. So now over here, if you see, 2 times we get a difference of 4. Over here only there is a difference of 6. We have to find the wrong term in the series. Okay, what happens over here? 14 and 28, difference is 14. That means it is like sort of being doubled, right? It is being doubled. Over here also 68, 136, difference is 68. So it is being doubled. So say here it is 4 and then doubling is there. Here it is 4 and doubling is there. Here it is 4 and doubling is there. So there must be some problem over here. Here also it should be 4 and then doubling must be there. Okay. So here what happens is that 6 is getting added, then we get 34. Say if we add 4 over here, what you will get over here? 32. And difference between 32's double is 64. So we are getting a very correct series. That means the wrong term over here is 34. Okay, because of 34, what is happening? We are finding that 6 is getting added and only 30 is getting added. We are not getting this kind of relation, 4 and double, 4 and double. Okay, so a common relation should be there. We found what kind of relation might be there. We were doubtful. So what we did, instead of after 28, instead of adding 6, we added 4. What we got as 32, double of 32 is 64. So what we have over here is the correct series will be 10, 14. 14 twos are 28. 28 plus 4 is 32. 32 twos are 64. 64 plus 4 is 68. 68 twos are 136. So we have add 4 and then multiplied by 2. Okay, moving to next question. Again find the wrong term. Okay, 15, 16, 20, 30, 45, 70. Now we don't know how to start, so let's see the difference. Here the difference is 1. 16 minus 15, 1. 20 minus 16, 4. 30 minus 20, 10. 45 minus 30, 15. Okay, 70 minus 25 is how much? This is 25. So over here, okay, difference is steadily little by little increasing. It is not going too fast or something like that. But if you see, there are some common numbers which when you see, the first thing that you get to know is there is a specific thing that comes to your mind. Like for example, whenever you see 4, you will say, okay, 2 square is 4. Whenever you say 9, you say, okay, 3 square is 9. whenever you see 25, you say 5 square is 25. Or if you see 27, you will immediately say 3 9s are, or 9 3s are is 27, or 3 cube is 27. Like over here it comes, it can be 1 square, this can be 2 square, this can be 5 square. So there is problem between these two numbers only in this pattern. Okay, there is a problem between these two numbers. So this difference, if it would have been 9, then this would have been 3 square. Okay, and if the difference is 9, that means this number has to be 29. Then difference between 29 and 45 would be 16. What it would be? 16. 16 is nothing but 4 square. Then the pattern is correct. That means this number which is there, it is not 30, it has to be 29. Then only we can get a nice series of 1 square, 2 square, 3 square, 4 square, 5 square. So the answer is 30. 30 is the wrong term. Correct term should be 15, 16, 20, 29, 45 and 70. So the difference here becomes 1, here difference is 4, here difference is 9, here difference is 16, here difference is 25. This is 1 square, 2 square, 3 square, 4 square, 5 square. Moving to question number 7. Find the wrong term in the following series: 1, 3, 10, 21, 63, 129. Now over here difference 3 minus 1 is 2, 10 minus 3 is 7, 21, here it is 11, 63 minus 21 is 52, 42, okay. 129 minus 63, it is 2, use 9 minus 3 is 6, 12 minus 6, 66, okay. So here again the difference which is there, it is increasing too much. So this must be like here, the see how it is 2, 7, directly 11, direct 42, direct 66. So it is increasing at a steady rate and quickly. So this must be somehow related to multiplication. But what multiplication? 1 into 3 is 3, okay. 1 is here, 3 is here, 10 is here, 21, 63, 129. 1 into 3 is 3. But 3 into 10 is not a multiple of 3. We at max can write 3 into 3 is 9 and 9 plus 1. But then over here again 10 into what? 2 or 10 into 3 is 30. 30 minus 9 we'll have to do. Okay, 30 minus 9. 10 into 3 minus 9. Then 21 into 3 is 63. So there is no as such direct relation when it comes to multiplication also. But so the reason I have taken this example is to show you how complex or how combination works. Okay, let's see. What is 3? Say if we write 1 into 2 plus 1, what you will get? 1 2s are 2, 2 plus 1 is 3. Now after that, now we have to come near 10. So 3 into 3 is 9, 9 plus 1 is 10. We have to come to 21. We have 10 into say 2 plus 1 is 21. So over here it so happens is that this is multiplied by 2, this is by 3, again it is 2. Let's see over here, 21 multiplied by 3, directly we are getting 63. Okay, so here multiply by 2 plus 1 is there, multiply by 3 plus 1 is there, multiply by 2 plus 1 is there. So this should be multiply by 3 plus 1. So answer should be 64 over here, but still we'll check. Okay, 64 2 3 2 3 2, 64 into 2 plus 1, 64 into 2 is 128 plus 1 is 129. So answer has to be 64. This is the wrong number. Okay, see how when you see such a pattern 2 3 2 like that, when such pattern is seen by you, even if you don't have much enough evidence to prove it, what you can do is you can take a hunch and you can try it, just like I did. What I assumed that okay, this 63 might be wrong, let us assume this pattern only and write 64 and let us see if the next number checks out. Okay, such trial and error method is always needed in series, otherwise you won't get the answer quickly. Moving to question number 8. Here we have 3 2 8 12 13 24 18. Okay, so again up down, little bit up down is there. So we can assume that there are two series or two operations are being done. Okay, let us assume there are two series. How the series might be? It might be like this. Okay, like this. Can you see 3 plus 5 is 8, plus 5 is 13, plus 5 is okay. So here we have plus 5 plus 5 plus 5. Next series what we will have? 2 12 12 24 24 32 32 42, 2 and 12 difference 10, 12 and 24 difference 12. Okay, it can be 10 added, 12 added, 14 added, 24 and 32 difference 8. Oh, why difference? Let's see, 32 and 42 difference 10. So here we have two tens. So here there might be some problem over here. If this 2 is shifted over here, you will get 10 and 10 and you will get a proper, proper series. So say if this is 12 and if we add 10 to it, what you will get? You will get 22. And 22 again, when we add 10 to it, what you will get? We will get 32. So that means the problem is over here. Okay, correct series has to be 3, 2, 8, 12, 13 and 22. Then 18, 32, 23, they will follow. So what will happen? 2 plus 10 is 12, 12 plus 10 is 22, plus 10 is 32, plus 10 is 42. Answer is 22. So correct answer is 24. 24 is the wrong term. Moving to next question. So here we have 1, 11, 34, 75, 139 question mark. Okay. Let us find the difference. 11 minus 1 is 10, 34 minus 11 is 23. Okay. 75 minus 34 is 41. 139 minus 75 is 9 minus 5 is 4. 13 minus 7 is 6. So this is 10. So here I am not able to find any relation directly. So what I'll do is I'll use another method that I'm going to teach you now, that is triangular method. You can try to solve the sums by this way also. Try to find a pattern using this way also. If you are not getting a pattern immediately in the second line, what you can do is you can try to find the difference again. 23 minus 10, 13. 41 minus 23, 18. 64 minus 41, 23. Okay. Again over here 13 and 18 difference is 5. 18, 23 difference is 5. See, now here we have a pattern that 5, 5 is there. So 13 plus 5 is 18. 18 plus 5 is 23. Then 10 plus 13 is 23. 23 plus 18 is 41. 41 plus 23 is 64. So how to find the next one? Very, very easy. If this is 5, this is 5, this will also be 5. So 23 plus 5 will be how much? 28. Okay. Then 64 plus 28 will be how much? 8 plus 4, 2, 6 plus 1, 7, 8, 9, 92. Okay. And 139 plus 92 would be how much? 9 plus 2 is 11. 1, 3, 4. 4 plus 9 is 13. 231. So 231 would be the next number. This is known as triangular pattern. If this is also a way of thinking. This is not a way to solve any sum. This is a way of thinking to find. This is a way of finding the pattern or trying to see if we can find a pattern, right? Just like we try square, we try cube, we try the triangular pattern also. Moving on. Okay, here we have 28, 33, 31, question mark, 34, 39. Okay, so 20 difference. 28 and 33 difference is 5. 28 plus 5 is 33. 33 again it has gone down. Oh, so it is up, down, up, down. So what we can do is that we let's see. First, we don't know this middle number, so we are not sure whether it is up, down, up, down, up, down, or whether this is only one incident. Let's see. 33 and 31. What is the difference? 2. Okay. So this is plus 5. 33 minus 2 is 31. Now here we don't know anything. Here we don't know anything. 34 and 39 is plus 5. So here we have plus 5. Here we have plus 5. After plus 5 we have minus 2. So it might be a series like this. Plus 5 minus 2. Plus 5 minus 2. Plus 5. Okay. So let's try whether this series is correct or not. 28 plus 5, 33, minus 2 is 31. Plus 5 would be 36. 36 minus 2 would be 34. 34 plus 5 would be 39. So we are getting a valid series over here. So 36 is the answer. Okay. See how easy it is. This is called as the combination of addition and subtraction series. Right. Series is actually very easy if you just know how to approach them. You just have to approach with confidence that you will get the answer. Try after trying the basic series of addition, subtraction and all that stuff like prime and Fibonacci, try the combination also. Okay. By most of the times, I'll tell you, in 95% times the basic series would be enough. You will be able to deduce using the basic series and the triangular pattern which we saw right now. If you know the basic series like squares, cubes and all that stuff, 95% sums of which are related to series would be solved by you. Just practice, only practice will give you the expertise when it comes to series. So keep on practicing a lot. This is it for series. You can check other reasoning and quantitative aptitude tutorials on our channel. Also check the job forum on careerright.com for latest jobs in the market. Share the video with friends and give it a like if you liked it. Leave your comments and suggestions for us, and don't forget to subscribe to our channel for upcoming tutorials and videos.